Okay, today we're going to talk about, well, more rules related to exponents and how we combine like bases with exponents. The first rule we have here is if a number is raised to the zero power, what's the answer? If a negative number is raised to zero power, what's the answer? If anything is completely raised to zero power, what's the answer? It's 1. The one thing we cannot have a equal to 0. Non-zero real number. What's that even mean? Means what it says, non-zero. Meaning, watch this. Okay, any positive number, any negative number can be raised to zero power, but 0 cannot be raised to zero power. It's illegal. It's against the rules. The math cops will come get you. So, our example in the purple box, 17 to the zero power equals 1. There we have it. Now we'll work on the example number A. What does it equal? 1. Now for B, it's a little different. We have 7x to the 0. What's the answer? Now, understand, 7x x to the 0, 0 does not cover the 7, so to speak. They're separate. We'll see what I mean in a minute. See? That's the answer, 7. 7 times x to the 0. X to the 0 is 1, and it's still times 7, so the answer is 7. Now let's look at C. We have negative 23 raised to the 0 power. We could assume it's 1, because it says negative numbers, right? But negative 23 is actually separate. It's negative 1 times 23. 0 does not apply to the negative. See, that's the answer, negative 1. Because the negative of negative 23 is separate. It's negative and then 23 to the 0. So the answer is negative 1. Now we'll look at the D. 3x parentheses raised to 0 power. Now we follow the power rule. We've discussed in previous vlogs that both the x and the 3 are raised to the 0 power. I expanded it to show the rule, how the rule works, and why it's different than the previous rule on B, 7x to the 0 as compared to the quantity, parentheses, 3x to the 0 power. I'm sorry. Excuse me, it's a little sloppy. If you were to see that, you can write the answer as 1. You don't have to expand it out like I did. Let's move on. Okay, here we go. Now we're going to talk about if we were to have a negative exponent, a raised to the negative n. We're not allowed to have negative exponents. We can't leave answers in negative exponent form. What we have to do, if we have a to the negative n, a to the negative n moves from the numerator to the denominator and becomes positive. So it moves to the denominator, and then n goes from negative to positive. So it's 1 over a to the n power. Positive n, that is. See, we have 3 to the negative 2 power. We move 3 squared to the denominator. It's positive 2. And now it's 3 squared. So 1 over 3 squared is 1 over 9. Now, if the opposite situation, if we have a negative exponent in the denominator, see, we have the denominator 1 over a to the negative n moves up and becomes a to the positive n. Now we had 1 over x to the negative 3. That denominator moves up to the numerator and becomes x to the positive third power. Remember, same thing here. We cannot have a cannot equal 0. The reason being, and I'll show you why. Right now we can see, can we divide? Can we have the divisor of 0? No, it's undefined. Okay, now you can see why. A cannot equal 0. Let's move on to our examples. We have 3 examples here, and they're relatively short. A example is 4 to the negative third power. Now, it's in the numerator because it is a whole number. Sorry, my writing's pretty sloppy today. I apologize. I made it clear that 4 to the negative 3 is in the numerator. We already knew that, but I'm just clearing it up. So now 4 to the negative 3 gets moved to the denominator, and it becomes 4 to the positive third power. And you can figure that out to be 1 over 64. Now, for b, we have x to the negative 4. It moves to the denominator and becomes 1 over x to the positive 4 power. Now in C, with the opposite situation, if the denominator has a negative exponent in it, you move that variable with the exponent to the numerator and it becomes positive. Some students felt like, well, we'll just switch them all. We'll flip-flop our fractions. We're not flip-flopping. We are actually moving each variable for each exponent. It may look like we're flipping fractions, but we're not. When we moved the x to the negative 6 to the numerator, we moved it up and 1 was left down in the denominator. Thanks for watching this vlog. I'll see you in the next vlog.